the India Space Congress 2026. Before we begin, I request you to please switch off your mobile phones to silent mode or kindly keep it to the silent mode. If you need any assistance at this point, our SIA volunteers are stationed around the hall and are happy to help. Thank you. Now let's begin this session. The session is Global Launch Hub, Reusable Launch Vehicles, Propulsion, Reflight and Return to Earth Systems. As the world races towards rapid reflight, reusable systems and lower launch costs, this session explores why India could become the next global gateway to orbit. This discussion will examine launch, recovery, and return to Earth technologies that are redefining the economics of space transportation. To chair this important discussion, it is my privilege to invite on stage Shri Muthupandian, Project Director, Reusable Launch Vehicle Program, VSSC, ISRO, whose leadership and contribution continue to play a significant role in advancing India's reusable launch capabilities. Welcome, sir. I also warmly welcome our distinguished panelists to the stage, Mr. Nilanjan Ghosh, AGM Manufacturing at HAL-Aerospace Division. It's my honor to welcome you, sir. Mr. Abrahim Cherian, Executive Lead, Flight Dynamics and Control, Agnikul Cosmos. Welcome, sir. Mr. Puneet Balasubramanian, Head of Business and Strategy, Astrobase. Welcome, sir. Mr. Raghav BM, Joint General Manager, L&T. Welcome. And I would like to call Ms. Shri Supranayi, Founder, AnduraX. Welcome, ma'am. The stage is yours, sir.
Hello. Good morning to all. First of all, let me thank the India National Congress, the organizing committee, for inviting Project Director of Reusable Launch Vehicle Project at the VSSC ISRO for this event. So along with me, the participants from L&T, Astrobase, Agnikul, and HAL and AnduraX have joined. So our time is only 45 minutes from now. So what I thought, I will give a brief introduction and followed by the introduction by the participants. Then we will talk about in details about the RLV and its applications, scope, areas of interest, and where private industry can contribute for the development. I want to just inform that ISRO has started its RLV program around 2000. More than 20 years of investment has been made in the reusable launch vehicle program, mainly the winged body, inspiration by space shuttle, that time in around 2000. So it was started as a small R&D project with a minimum budget. Our aim was to do flight testing experiments so as to acquire the final fully reusable launch vehicle, what we call two-stage to orbit. In that, the second stage can be the winged body. And the main objective is to achieve low-cost access to space, mainly for satellite launches. That was objective. See, we have started with the hypersonic flight experimental mission and lot of new developments, totally new. I will talk about the challenges involved in the RLV subsequently. We could successfully complete the mission in 2016, May 23rd, at Sree SGSC Shar. That was the first mission, and all objectives defined for the mission, which is a subscale version of the future RLV, has been completed. Subsequently, as a second step, we have gone for the autonomous landing experiments of the wing body, high-speed landing on the runway. We could spend about 4 to 4.5 years to do this experiment. In 2023 and 24, we could complete the landing experiments by using a runway at Chitradurga ATR. This was a very significant milestone in the ROV program because wing body has to come and land on the runway very precisely, and also the speed is very high, 100 meters per second speed, 360 kilometers per hour. Such a speed has to land very precisely within the runway distance of around 3 to 4 kilometers. It was very challenging and we could complete. So what I want to say, the necessary technology, infrastructure required for the development of reusable winged body exists in ISRO. Our next and final step is to demonstrate the end-to-end orbital re-entry capability of the wing body, which is under development, and we are planning the mission next year. So this is a background. So I am leading the project right from 2010. I am associating with the wing body program, and now I am leading the project, and under my leadership only we could complete the RLV LEX landing experiments in 23 and 24. And we have some challenges. We need some support from industry through collaboration by joint venture or by collaboration with other countries. It may be required. There are some key challenges in the orbital wing body, mainly in the re-entry phase, that I will talk about, and what are the limitations we have in ISRO, and what we look forward for the support from industry, and also the applications, where and all this wing body can be used, which are all the applications. Definitely huge applications are there. I will talk about one by one, not now, little later. So this is my background. With this, I want to talk our participants to have the introduction. Probably 2 minutes may be sufficient, because with this you can just talk each person about their company profile, their contribution to space sector, as well as how the company is linked to the reusable launch vehicles, if any, if it is there, or future anything they are planning to have such a re-entry program or reusable program. Relative to that, they can please discuss. We will start from the rightmost point. Raghavendra, please.
Hello. Thank you, sir, for the opportunity. So I'm Raghavendra. I represent Larsen and Toubro. L&T is a $33 billion Indian conglomerate. We are spread across various strategic sectors of this country, and also we have got an international presence in over about 52 countries. So having said that, we play a very significant role in defense, nuclear and aerospace sectors and space sectors in this country. When I go back to the development of space technologies, I would say we have been the first partners to ISRO right from the first launch vehicle, which was launched, that is the SLV-3 in maybe 75. From then onwards, every launch vehicle, every program that ISRO has embarked on, we have played some small role and learned a lot from this great organization called as ISRO, eventually building up capabilities that are required for this developing space technologies. So coming very quickly, briefly on what all we do, we are predominantly in the upstream sectors. We are building launch vehicles, subsystems for PSLV, LVN3, SSLV, and JSLV Mark II as well. And when the country opened up for private participation of space. We were the first company to get the first system integration order for building 5 PSLVs. So apart from this, we are also into building satellite subsystems and also actively looking at building our own satellite very quickly. This year we may have a tech demo on that. And we have played a significant part in developing very key test facilities that are required by ISRO, specifically the hypersonic wind tunnel or the shock tunnel, which is required for re-entry technologies. And we have also played a small part in being a part of the RLV program. In fact, first time when ISRO talked about involving private industry in the design phase. So we've got a small role there. I'll talk about it as we go further. And we are also playing our part in being a part of the NGLV design program as well, where my team is participating and learning from ISRO on to getting into the newer technologies. So having said that, we have been a major player in space as far as ISRO is concerned and being a major partner to ISRO. So looking further for various associations, going further, developing latest technologies that are required for the future. So that's all I have to say about myself and Lasnato.
Thank you. Next, Puneet, Balasubramanian.
Thank you, sir. Thank you for the opportunity. Coming in the shadows of a giant like L&T is always challenging. I am Puneet. I represent a young startup, which we are about 2 years old. We are headquartered in Bangalore. Astrobase is our company. For all of you who may not be aware about Astrobase, at Astrobase we are building a medium to heavy lift launch vehicle. We are covering the spectrum from about 500 kg up to 4.2 tons, which puts us slightly in a PSLV plus class category. So in terms of vehicle size, we are there. But more interesting for everyone present in the room is our propulsion stack. So we are building a FFSC rocket engine, which is the most advanced rocket tech in the world today. Very identical to the rocket tech being used, the engine tech being used by Raptor of Falcon 9. Our engine is an 80-ton thrust, so that gives an idea of the scale of the engine tech. So we are building a 80-ton thrust FFSC high thrust rocket engine out of Bangalore. Or one of our other facilities is our testing infrastructure. So as we are aware that testing is a very critical bottleneck when it comes to, particularly when it comes to testing of reusable engines. So we have commissioned India's first privately owned LOX methane rocket engine test facility in Andhra. And we have a 210 test bed fully operational. And as we speak, a very active launch campaign is in progress of our engine. And this is a very important year in our propulsion trajectory, because by the end of this year, we aim to successfully complete the full-scale hot fire of the engine, which will put India firmly on the global map of FFSC engine tech in the world. So that is about Astrobase, a very small team, but our core team, the engineers who are leading it, come with very strong heritage from ISRO. And we are a very small team as of now, but we have a very ambitious plan as far as launch is concerned. And our first launch is planned in the Q4 of 2028 or Q1 of 29. So that's it about Astrobase. Thank you.
Okay, thank you. Mr. Kevin from Agnikul.
Hi, my name is Kevin Cherian. I lead the Flight Dynamics and Controls division at Agnikul. Agnikul is a 8-year startup now. We've been building our own IP around the single-piece hardware that we have built, and the engine that basically flies with that single-piece hardware is what we've built our launch vehicle configuration around. In 2024, we had a suborbital successful launch that basically proved a few avionics and propulsion chain elements that we had designed in-house. This was done from our launch pad at Shri with the help of InSpace and ISRO support. And happy to hear that there is such an active interest in reusable launch vehicles, because we are also looking at reusability actively, and we are trying to catch and recover our stage in Q2 next year.
Thank you. Mr. Nilanjan, HAL.
Thank you, Chairman. I represent the aerospace division of HAL. I know HAL is always in news for LCA Mark 1A, but you will be glad to know that we are associated with ISRO for the last 5.5 decades. I think every mission of ISRO has something of HAL going into it, whether it's a launch vehicle or satellites. I think the lander, Chandrayaan 3 lander, was first in my shop and then it went to the south pole of the moon. It's a great achievement. What I want to bring to this forum is that HAL has got a vast infrastructure and expertise, skilled manpower to deliver a lot of launch vehicle systems and subsystems. Coming to today's topic, that is reusable launch vehicle. I think many will not be knowing that whatever frugal engineering or automation you bring into the structural side, that only gives you an cost advantage of 12 to 15%. But if you switch over to a reusable launch vehicle arrangement, I think the benefits are multifold. You get 40 to 45% of your savings out of it, which makes the launches much more cheaper. So today, as an industry, I think we should try to promote those type of technologies which will be efficient, quality certified, and cheaper. That should be look out. And I think in today's discussion, as we go forward, we will discuss many more things which will be of interest to all the participants and all the attendees. Thank you.
Thank you, Ms. Sree from AnduraX.
Thank you so much. Very good morning to all the delegates and entrepreneurs present here. I thank SIA for this incredible opportunity. Myself, Sree, I am founder of AnduraX. We as AnduraX are focused on industrialization of space. With the launch ecosystem becoming currently making space more and more accessible, we started looking into what's next. And the future of space is completely utilizing it as the extension for industries on Earth. Focused on that, we are building reusable vehicles or re-entry vehicles that enable the manufacturing in space or microgravity experimentation in space and bring back the payload landing on the runway. We are focused on optimizing the re-entry logistics on three aspects: cadence, cost, and precision. And that is where we are developing the vehicles for microgravity in space experimentation and eventually human space flight, aiding also to the Bharati Antariksh Space Station development of ISRO and the Space Vision 2047 to expand our boundaries into manufacturing in space.
Okay. Thank you. Now we have understood that our industry looks forward to go ahead with the reusable launch vehicle technology also. Now being 20 years of the program running at ISRO, I want to just briefly explain about the various aspects of the RLV, okay, for the benefit of the participants as well as for the benefit of the audience. It may be a well-known fact, even then just I want to highlight very briefly. See, RLV concept is actually recover, refurbish and reuse of the launch vehicle, either partially or fully. Already it has been successfully shown in the space shuttle, which has been used for about 35 years and it has retired actually. So it is a RLV concept. So our RLV program also started with that particular space shuttle inspiration only. So there are a lot of advantages for a fully developed reusable launch vehicle technology. Today the technology is not fully available. It may not be fully available in all other countries also. Limited way only it is being used and many countries are doing the development. I can say you that mainly the prime application of the RLV is low cost access to space. That was a prime objective of our ISRO to pursue the RLV program. And also we have the increased launch frequency and on-demand launch, sustainable ecosystem, space tourism, The one advantage of going for the reusable launch vehicle is to have the space tourism activities, which is currently in operational in some of the countries, but it can be actively pursued for this particular aspect, which is having a good potential for the private industry to take up this particular application, space tourism. And second point is, as Sree also told, the on-orbit operations. See, mainly there are new applications are coming up in the industrial sector to do the manufacturing in the on-orbit conditions where the gravity is zero, microgravity or almost zero gravity. When we make the products in the microgravity environment, it is the purity, the quality will be very high. There are no defects, highly homogeneous structure, which can eventually give them many benefits in terms of the operational time, efficiency, and in totally it will be reducing the cost. So this is one particular area being explored. Right now you may be aware that semiconductor industry, optical fiber industry, and also pharmaceutical industry, they are using the R&D efforts in manufacturing area of these products. Lot of inherent advantages which will lead to the benefits, cost benefits also by this. Okay, then again with respect to our international space station, or we are going to have our own space station, we want to have the docking facility, transportation of the cargo to and from the space station, and also to bring the valuable products from the space station. And one more point I want to tell you that in addition to space tourism one main application. Next is orbital manufacturing activities, which is only coming up, but it will have a lot of potential. Maybe after 1 decade, you can see that the orbital manufacturing is having a highest value in the market. Third one is there are a lot of military applications for this vehicle. So the winged body RLVs are being used by many countries, especially USA and China. They are using for the surveillance activities, which is much information not available in the papers or literature also. They are using it. You may be aware X-37B, one typical example. It is there in orbit for about months and years, and we don't know really what they are doing. It is very secret. So this reusable wing body has a very highest application in the military area. So that is one requirement is there. So this development is very important. Of course, satellite launch, as I mentioned, our aim is to have satellite launch. We can have, now we are doing the subscale model. We have to develop to bigger size. We have to use bigger vehicle to launch the satellites and come back. And also, as mentioned, we can do the satellite servicing, satellite fueling, satellite collection and come back. Overall way, we can reduce the debris in the orbit also. This is also an important requirement internationally. So these are all the various applications where the wing body RLV can be used. Just I want to highlight. Of course, the cost reduction will not happen in one day. It has to take a time. 10 reuses, 20 reuses, 50 reuses, 100 reuses. Like that, you have to plan your vehicle for many reuses. And the cost overall weight will come down. More than cost, there are applications which need RLV for its use that I mentioned earlier. Any RLV wing body development is a must. Whoever is there in the market and whoever is going to develop first will be the winner in the market also. Of course, we are doing it, but point is, I want to tell you in ISRO, the manpower is limited. Manpower, in the sense we cannot, even though the projects are more, manpower is not increasing proportionately. Now you are aware we have to develop a Bharati Andhari station. We have to develop a lunar mission, that is landing vehicle for lunar, sample return mission from lunar, Chandrayaan mission, and also Venus mission, and Gaganyaan mission, Gaganyaan follow-on mission. All missions are very complicated. It is not like very easily it can be done, but proportionately manpower is not there. But I want to tell you, the necessary infrastructure and expertise is available in ISRO. every engineer in ISRO has great knowledge in his area of applications. And all are very dedicated, committed, and they do a lot of applications. They do very sincere work and go and do and bring out the success. Okay, so what I want to tell you, infrastructure is available, expertise is available, and whatever support the industry wants to get for developing the new area of applications like RLVs can be utilized. Only thing, manpower is less. So unless the private industry participates, we cannot achieve all our program as per the schedule. That is the most important point I want to highlight. Everywhere, delays are there in our program. It is not intentional delays. Everybody is hard working in ISRO, beyond office hours, Saturday, Sunday, depending upon the requirement. Even then, lot of technical challenges are there in the new design and development. So we have to find the solutions, do the testing, clear the issues, then only we can go for next level. So private industry participation is a must, because I can tell you, India can provide very cost efficient solutions for any problem. That is the biggest advantage of India. In the morning also, people are telling about, even Taiwan and other people also, Thailand people also were telling, somewhat economical solutions we can get from India compared to other nations. You can see in the net also what is the cost of investment in other countries and cost of investment in space sector in India, how far we could achieve success. And also the Indian manpower also, very good skilled manpower is available, which can be potentially used for many new applications at an economical rate. That is the biggest advantage. So this can be used. So this is the message I want to give you. So private industry has to participate in the RLV area also. And as our Nilanjan mentioned, see the reusable cost, I want to mention you, around 60% of the cost we are spending in the materials and fabrication of all the systems. If you use these particular systems and structure multiple times, the cost will come down. And 20% cost for the propellants and consumables, and we have to refurbishment cost also around 20%. Okay. So next I will talk about the disadvantages of this particular reusable concept compared to launch vehicle concept or any other application. Here we have to spend a lot of time and money for the initial R&D efforts. Being a wing body, we need very clear aerothermodynamic characterization of the wing body by using CFD simulations, by using wind tunnel tests. So this is the biggest challenge. We have to spend around years we have to spend for characterizing the vehicle. But fortunately now we have characterized one particular configuration of wing body which is flyable. So there is no need of such a further characterization. But we have to do some additional testing like high enthalpy test and even plasma wind tunnel test to characterize about other systems. Next one challenge is actually the TPS design, thermal protection system, because our main body is mainly aluminum or composite structure, which can withstand only 175 degree maximum temperature, and the internal compartments also has to be limited by 60 to 70 degrees because packages and sensors are sensitive to temperature. So we need advanced TPS system. Even though we have the developed TPS system for our application, still advancement is required in terms of cost and in terms of density. We have to seek some more advancements. Okay. And third point, which is most important, which we are facing now in ISRO, what I want to tell you now, next year we are planning to do the mission. That is a target. I have committed also 3 years before. And all systems like landing gear system, control activation system, avionics system, control and guidance design, and propulsion system, TPS system, everything is going on in a good progress is there in every system, because all systems we are only expanding or extending to the new vehicle, because all systems and technologies are available. The only thing is hot structures, because it has to face the re-entry environment where the temperature is expected to be more than 2000 degree. So there we need the nose cap and some of the leading edges, control surfaces we have to make out of hot structures, which is called the carbon-carbon and carbon SiC or SiC-SiC. Even though we have the technology for the hot structure development, we are not having the facilities for the processing. Very limited processing facilities only are available in India, not only in ISRO. In the whole India, we have seen that limited facilities only are available for processing the hot structures. That is one biggest drawback we are seeing. See, we are now exploring the other countries also to get facilities for manufacturing. I want to tell you one information that we have identified some 3 companies in India to make one product, because each company has its own processing furnace. So there are three different processings are involved in the carbon structure. One fellow is having one facility which can do only one particular processing. That is not sufficient. So we have to do one more processing, then I have to go for another industry, one more processing, third industry. So like this, now we identified last week 3 companies in India can make a larger size composite structure, that is hot structures. That is the latest development. Now we cannot, the problem is again, we cannot give the order to 3 companies. I have to give one single company and he has to coordinate with the remaining companies to get the product. So the point what I want to tell you, in the international levels I have seen only one company is having a biggest furnace to process a larger size of hot structures. So that is one lacuna I am seeing actually. So probably this area can be considered for further investment by the private industry. Single industry investment is not sufficient. There should be a collaboration with multiple industries, because a huge investment may be required, and they can collaborate with external industries also, foreign industries also, so that there can be a full-fledged facility for processing sector, larger size structures, because reusable wing bodies are going to be there in the future. It is going to be a continuous requirement in future also. Considering all those things, the industry can think about investing in the processing sector. Okay. Next, one more drawback what I am seeing is actually the thermal insulation. See, the hot structure and cold structure, I told about 175 degree and 2000 degrees centigrade. So the 2000 degrees centigrade fellow has to be connected to 175 degrees centigrade fellow through an insulation system, which can drastically reduce the temperature from 2000 to 175. So the other systems will be safe. So it should be confined, very limited space. We have to develop the thermal insulation scheme. We are also having some scheme which is under development and testing only. So the full-fledged technology for the hot structures, fabrication and the thermal insulation is being evolved. That is the message I want to tell. So this area, private industries along with other industries, they can think about investment, which will have potential applications in future. Okay, now again just I want to inform one more point. What is available in ISRO? As I mentioned here, we have the necessary infrastructure and facilities in ISRO. I already mentioned. Just I will read what all the facilities we have. Wind tunnel, shock tunnel and plasma wind tunnel facilities are available. Even for any Mach number, okay, there are some limitations, but even then the augmentations are going on, so there won't be any problem. We can do the testing of the structures, mainly reusable vehicles. We have to subject it to this kind of the plasma wind tunnel test, shock tunnel test we have to do, high enthalpy test we have to do to characterize our TPS system. And we have vibration and acoustic test facilities in ISRO available. Thermo test facilities available in ISRO. Structural and thermostructural test facilities are available. Simulation test beds are available. We are mastered. We are mastered in the control and guidance design for any launch vehicle as well as for reusable launch vehicle. We have the simulation test bed also, that also can be utilized. And also technology on control actuation system, guidance and control system, mission design, TPS, avionics, navigation system, everything is available in ISRO. And a very good technology is available, but still advancements are going on in every area. Okay, as I mentioned already, there are 3 steps we are planning for the reusable launch vehicle technology development. 2 steps already we have completed very successfully. The 3rd step we are in the path. Probably 2027 or 28 we are trying to complete, and all the difficulties are already told. So with this background, let me complete my presentation now. I want to listen to our participants as well as from audience related to RLV and their contribution for the wing body RLV. Whatever is there, it can be discussed. Okay, again starting from Raghavendra, you can just take.
Hello. So once again, thank you. Uh, just now looking at what we have built over the last 5 decades is a system of quality, which we call it the ISRO's quality systems, which is very essential for going further in this kind of an endeavor as well. So if we look at some of the key technologies that has been built over the years, like we spoke about the hypersonic wind tunnel or the shock tunnel, which is required for characterizing the flow dynamics, which is established. Of course, it took a lot of time and energy in actually materializing such a mega project. It took a couple of years with a lot of to and fro's to having developed that. And apart from that, we also have developed a high altitude engine test facility also in Mahendragiri for ISRO. Now, one good move which has happened in the recent past is for the first time, ISRO involved industry in the design. So we have moved from just build to print partners to build to spec partner. That was one very good move which has happened. Even though it is in a small part, we got an opportunity to be a part of RIA interface adapter.
That's a good point. Now, we have started encouraging industry to give us a total package. Total package is given as a requirement, like one structure, design, realization. Probably testing also we can add in the future also. So design and testing, design to testing, the entire cycle they have to complete and give the hardware to us. That is a initiative has been taken, and first time we have given to L&T on a biggest structure, 3 meter height and 2.6 meter dia, composite structure. We have given the configuration, we have given the record properties, we have given the loads. So they have to do the design and they have to manufacture, and it has to be proved by testing also. That's a good point. Yeah.
So this thought process needs to be expanded. It is one small structure we have got into. Probably we can look at larger collaboration in this, because today, if you look at what has happened in other sectors like defense, the entire system of systems are built by the private industries. So I'm not saying that they are capable of doing it, but we have the elements required to actually do that. So this is where actually involving industry very early in the design phase makes a lot of difference. Not just understanding the design aspect of it, but also the manufacturing nuances required. So design for manufacturability is also one more very important aspect which generally get neglected, because designer's dream is a manufacturer's nightmare. This is what we know about. When we build some of the complex systems, we realize that this is not manufacturable at all. So we need to now go roundabout and do something differently. That's where new technologies like additive manufacturing came into existence, where what you could think of, you can actually print it out. But again, there are limitations there, again, when we go to that technology as well. That was the first of the example. Second, I would like to also talk about our participation in NGLV program. Again, that's another area where ISRO involved industry in actually in the design phase of NGLV, where
And NGLV also now they are planning to give us a total package. It looks like many systems they will select and give the total system.
Yeah, it makes a lot of difference, because, see, of course, there may be some technologies which may not be available in the country, and we may have to depend on or bring a foreign partner for some of the technologies. For example, I'm talking about a system like integrated life support system. It is, we have to develop from the scratch, or we can tie up with somebody who has already done multiple times in the worldwide. So that's an also aspect which we can look into on how we can go ahead with this. Now, having developed some of the systems, like, for example, there is a concept in defense, DRD, I'm just taking a parlance. It's called Develop Come Production Partner, Development Come Production. This is DCPP. A program like a complete aircraft like Ghatak, which is as big as LCA Tejas, or slightly bigger than that, has been given on a DCPP basis, where industry had come out with a complete design of the airframe. And we are going ahead now realizing the complete aircraft. So that can be taken as an example of how we can, even when building RLV also, we can, having built wings for LCA Tejas, how that learnings can be deployed in building the wings for RLV as well, or the complete body of the RLV. So these are some of the thoughts which I had, I thought I should share going further.
Thank you. Next, yeah, Puneet.
Thank you, sir. First of all, thank you for the great insights which you just shared. Not going very much into technical aspects here because I've got great experts here on technical matters. But one of the points which we want to highlight is that while we definitely agree that reusability brings in cost advantages, but that's only one side of the story. Yesterday I was watching the Titan story, and there's a beautiful line in that innovation is always exclusive. It's only distribution that makes it affordable. So when we talk about, when we draw a parallel with launch vehicles, we can see that, the rocket itself is a great innovation. But reusability is actually what is likely to bring in distribution in it. And we are seeing that happening on the global canvas as well. So if we just look at the number of launches in last year, so there were about 330 orbital launches last year. And a little more than half of them were from a single reusable vehicle. So the concept of reusability today is no longer something which is futuristic. It is clearly and clearly present in front of us. The commercial viability of it is present in front of us. The challenges which it is going to pose to launch vehicle companies in times to come is in front of us. It's going to be commercially more and more difficult for launch companies to because the launch costs are getting cheaper by the day. So cost is definitely one side of the story. But also I often think of reusability. What reusability is going to bring into the launch vehicle segment is something which probably 4G and 5G did to digital economy. They not only brought faster internet speeds, but they enabled a whole new ecosystem of businesses and applications which the world had never thought of before they came in. And once reusability comes in, it's not only access to space which is going to be more frequent, more predictable, more responsive, but it is the entire ecosystem of applications, be it Earth observation, communications, in-orbit logistics, and even businesses and applications which we may not have thought of today.
Yes.
But those are going to emerge once reusability is firmly a matter of routine, particularly in the Indian ecosystem. So that's a point which I try to bring in. And there's one aspect in all my interactions with all our global partners which is emerging, is one single aspect from the customer is predictability. Predictable launches. If we say that we will launch on the first of every month, we need to launch to orbit first of every month. If we say that we are going to do a fortnightly launch, we need to launch. Predictability in launch is something which we all those associated with launch companies, it's not only the launch company which is going to achieve this in isolation, it's the entire ecosystem which is going to enable it. As sir also mentioned that supporting ecosystem is vast in this space. Not going into specifics. If that comes up, I'll be happy to share. But we all need to collab and get that predictability into our DNA of launch, because only when the entire supporting ecosystem is in place can we achieve that single most important factor when it comes to launch is predictability. Thank you very much.
Okay, thank you.
I think we've heard really great points so far from a technology standpoint from Sir, and how private industries are now beginning to participate even in government activities in terms of pushing the boundaries of what space is having in India. And I think pushing the boundary is where the theme of this particular decade is for India. And my simple look at it, at least from the perspective, is there is a certain change in the way in which we approach ambitious projects. I think a simple example of that is how the private sector got access to space in 2020, and how now ISRO is also actively engaging in design with private entities. And even on the customer front, when we, I think like how Puneet mentioned, being able to be upfront and present with the customers to show that, hey, we are a viable option and we are predictable in being able to provide a launch service. Those are statements that are very common, very plain in the West. You cannot talk about any vehicle today meaningfully without having an element of reusability. There is, I think SpaceX has done a certain set of things that has driven the launch cost in a certain way. But what is again key to their success is an ambition that is visible right from how they've operated to where they are today. And that ambition, I believe, is important even for our customers, for the investors, for the government trying to do bigger things, for the people joining the workforce to do bigger things, better things. And I believe that it will be a key part of, like the industry and the government and ISRO has a key role in pushing that ambition and encouraging that ambition in this particular decade. I think reusability just comes as a byproduct of that for now.
Yes. Yeah, thank you.
See, India can become a global launch hub if we have the capability, if we have the capacity, if we are a low-cost solution provider, and we continuously innovate so that we are still relevant in future and maybe one step ahead of other countries. I think everyone present in this hall wants to understand that how they can connect with this type of concept. Okay. Academia, I think plenty of opportunities for you to participate in the future programs. There are many entrepreneurs who have already invested or in the process of investing. For them, one thing I want to tell you that lot of expertise and infrastructure exists in the country. Maybe it is with a few agencies. Okay. ISRO is the main principal. HAL has lot of capacity. L&T is coming up. Godrej is expertising in engines. So I think you have to take advantage of this. The big players who are already existing, how you can collaborate. Similarly, we are also now opening up, we are trying to collaborate not only with industries, with academia, because we feel that industry cannot spend a lot of time and money in the innovation part. Okay, so we are going to fund, we are trying to involve academia, get innovative solutions, and then try to commercialize through industry, and then only we can say that we are going to become a launch hub in the future. I think the chairman very clearly elaborated on the RLB program. Okay, what are the stages achieved, what are the potential in future, and where we stand today. I think NGLV, the next generation launch vehicle, is going to operate totally through a reusable model. The first stage, which is I think 50 to 60% costing of the total vehicle, okay, cannot be just dispensed with one launch. It has to be recovered, it has to be refurbished, it has to be relaunched. Today, if you see Falcon 9, the first stage has gone for 34 launches. Okay. Similarly, I feel working in the manufacturing domain, I feel the type of design what ISRO has made, the type of materials, the process what we have selected can be utilized very much for multiple usage. So, I think the reusable launch vehicle only will be the type of concept in the future, and NGLV, I think right now what we can launch through GSLV Mark III is only 10 tons to LEO. NGLV can launch 23 tons to LEO. That means if you have to put your BAS by 2035, only 3 launches of NGLV will be sufficient to transport the payload. So these are something I think which should trigger everybody available here, present here. Please think that this is the future, and if we let it go, somebody else will come and take those opportunities. Thank you.
Thank you. Yeah, Sree.
Yeah, thank you so much. Sir has very well detailed on the necessity of re-entry logistics or RLVTD program in the complete loop. How we are building it is we are, for the re-entry vehicle, we are building a lifting body architecture with a parafoil based landing. The moment you do stack ranking, the top 300 experiments that can be done in space become pharmaceutical. The complete protein crystallization process and expands into semiconductors, optical fibers, and advanced materials. Now, all of this requires smooth recovery from space, and the lifting body architecture we're building ensures the re-entry with almost 1.5 G, and the runway landing with the parafoil-based system ensures the payload can be recovered quicker and handed over to the labs. So, along with that, this application expands into defense, as Sir said, for the ISR application, surveillance, rendezvous operations. It completely builds a strength for the space warfare layer and the sovereign capability we are trying to build in India. As an industry, we are working on also for the challenges you have mentioned in the re-entry ecosystem. We are working on building the thermal protection system, carbon-carbon composite, with industry experts who have worked on these high enthalpy materials for ballistics. Second critical point for re-entry becomes the autonomous guidance, navigation, and control system, for which we are happy to share that we have recently done our first drop test validating our complete GNC stack 1 week ago. And are also targeting precision landing by the end of this year, first re-entry demonstration in 2028, and first space plane launch by 2030. Another critical infrastructure is also the OTDM, onboard trajectory determining module we are developing in-house to ensure the complete vehicle or the re-entry logistics is optimized in three aspects, as I said: cadence, cost, and precision. We're targeting monthly cadence, eventually weekly cadence, and 10 years down the line, we would require daily cadence, daily re-entry operations going on from space and back to Earth. That is the only way we can fully capture the advantages the microgravity environment offers to the industries. Adding to what we require from industry, adding to what Sir has already mentioned, how we should collaborate, another point I would say is the subsystem development we need. 18-month lead time has become a very common thing in our segment. This becomes a big bottleneck for the acceleration and the pace we are targeting in the development process. Now, as more industries come together for the subsystem development, making it indigenous, building all it under one roof, increasing the reliability and reducing the lead time, will also aid in the development acceleration of it, along with the infrastructure and manpower. Thank you.
Thank you. Okay, I understand that our ISRO has given the necessary information to the private industry so that we are able to see that they are also started their investment in the reusable area. Particularly AnduraX is going to make even reusable launch vehicle, and experiments they are planning, and the NGLV related information also HAL is planning. Like that, it's a good beginning, and we are happy to note that the private industry also started in thinking about the reusable concept and investing in the reusable area. Only ISRO can provide a lot of the areas where it can be invested and where the applications can be explored. And another point I want to tell you that through NCIL or through InSpace, ISRO always can be contacted for any support for the development of reusable area. That is always welcome. Okay, thank you for all the participants. A very nice interaction. I hope that audience also would be benefited by this useful, lively interaction. So we are due to short of time, we are not able to get any questions from the audience. Anyway, we are here only. We can ask your questions in the lunch time or in the evening, so that I can also answer to your questions. Thank you. No, I'll be there giving you a paper because next session is there actually. Thank you very much.
Thank you very much, sir. A very warm thank you to our distinguished chair and esteemed panelists. That was a conversation the Indian space industry needed to have, and have loudly. May I now request all our panelists and our esteemed chair to please come forward for the group photograph.